With the popularity of Bambu Lab printers, it's no surprise that we've seen all sorts of add-ons and upgrades released for them. For a long time, printers required mods and part swapping to get any sort of reliability. But for many of the modern machines, this is at the point now where it is optional. Thanks to stiffer machines, external cooling, and firmware advancements, we can print faster without much of a hit to quality. But the Hotend's max throughput is still a common bottleneck. For the Bambu Lab X and P series specifically, we've tested a couple different high flow Hotends, but for the A series, due to its unique Hotend design, I wasn't sure that we were ever going to see them. So I was pumped to see a post from Microswiss a couple of months ago showing that they were releasing exactly this. I reached out to Microswiss expressing interest in testing this new Hotend, and they agreed to sponsor this video. In this video, we'll dive into this new CHT Hotend for Bambu Lab A and H series printers. We'll go over some specs, get this installed, and run plenty of flow tests. So with all that being said, and without further ado, let's get right into today's video. Let's dive right in and get this unboxed. Inside, we'll find some instructions on how to install this Hotend into the H2D and the Hotend itself. Unlike most of the other Microswiss Hotend installs we've done, there is no thermistor or heating element that needs to be swapped, since that is part of the internal toolhead assembly. Instead, we have the heatsink with built-in heat break, along with the connected heat block and press-fit Bondtech CHT high-flow nozzle. Microswiss states that this design can give you up to a 50% increase in max volumetric flow, which we'll test shortly. Outside of the flow increase, the nozzle is made of heat-treated M2 hardened high-speed steel, and it's coated with non-stick nano WS2, which should be helpful for materials that like to pull up around the Hotend, such as PETG. The nozzle orifice on the unit we're testing today is 0.4 millimeters, but they do also come in a 0.6 and 0.8 millimeter variant. Comparing the Hotend to the stock one I pulled out of my A1 Mini, the main external difference that we can see is in the heatsink and at the very top of the heat block. The heatsink on the Microswiss Hotend is shorter, with a portion removed from the middle, allowing for additional length of the block. This isn't something I'd seen before, but later in this testing, I pull my stock Hotend out of the H2D and realize that the design between the two on the heatsink and heat block is very similar. Swapping out the Hotend on these printers is so simple that I was debating on whether I should even cover it, but for anyone that hasn't ever replaced a Hotend on their A series or H series printers, we will quickly run through that. The first step is to remove the front cover from the tool head. For this, you'll use your nail or a small flathead to get in behind the cover and then just pull it away. It's only held in with clips, so once you get a little bit of leverage, it will pop right off. Next, pull the silicone sock off to expose the Hotend and the latch mechanism that is holding it in place. Pull the latch forward to release, then swing open the hinged metal clasp. Without that clasp, the Hotend is only held in by a magnet, so grab the Hotend, pull it towards you at an angle, and it should pop right out of your toolhead. It can be a little bit awkward to remove it because there's usually a piece of cut filament that is sticking out the top of it. To install the new toolhead, we will do the exact same thing, but in reverse. Make sure you have the magnet side of the heatsink facing inwards and set the Hotend in place. Then swing the metal clasp around the heat block and push the latch to snap it in place. If you're having issues getting that latch to close, it typically means your Hotend is not far enough up in your toolhead. So my recommendation is just to remove it, try reinstalling it, and again, make sure that it is all the way up. It shouldn't require very much effort to get that latch to lock. Then install the new silicone sock. While they are similar, because the Microswiss heat block has that little extension piece on the top of it, you will need to use the one that comes with your kit. Finally, place the front cover back on and press in so that it all clips into place. And that is it. Once you've done it a couple of times, it's like a 60-second swap. It is really fast. Really, the primary thing I was interested in testing was the max flow rate of a couple different materials between the stock Hotend and the high flow Microswiss one. So before I swapped over, I ran a series of flow tests in PLA and PETG. For this, I used Orca Slicer and went with the built-in generic material profiles. To get a baseline, I swapped over to the Bambu Lab basic PLA and PETG profiles to see what they had the max volumetric flow set to in those defaults. Based on this, for PLA, the test I ran started at 15 cubic millimeters per second and ended at 30. And for PETG, I ran from 10 to 25. For PLA, the test looked pretty good up until 25 cubic millimeters per second, where I started to notice inconsistencies in the extrusion. And by 28, large gaps appeared in the walls. As for PETG, I noticed a pretty drastic change in the material's sheen around 15 cubic millimeters per second. But the quality still looked pretty good up until about 23, when the layers became displaced and just looked rough. After swapping to the new Hotend, I ran these exact same tests again. The PLA test completed without any sort of gaps or imperfections. For PETG, I noticed a similar change in the sheen around 15 cubic millimeters per second, but this returned around 20, and the test completed without any noticeable hit to the layer or extrusion quality. I followed this up with a 30 to 40 cubic millimeter per second test in PLA, and was surprised to see it once again complete without any obvious imperfections. So I ran a final test from 40 to 50. By 44 cubic millimeters per second, the large gaps that we saw using the stock Hotend at 28 appeared, so I am calling this the maximum. With any of these tests, I never recommend running at the absolute peak, but I'd feel pretty confident in scaling down to say 38 to 40 cubic millimeters per second for my profile, depending on what I was printing. For the PETG, I scaled the test up to 25 to 35, and it completed without any issues. Then I ran a test from 35 to 45, and while it completed, there was a fair bit of bumpiness on the inner walls of the test print. Just for fun, I started another print from 45 to 55 cubic millimeters per second, but it failed hard very quickly, so I stopped it after the first handful of layers. Because of the imperfections I saw in the second wall of the PETG print, I'd want to do further tuning before dialing in a profile, but I'd probably start a little under 35 cubic millimeters per second. I don't print any ABS or ASA on the A1 Mini and have no plans to do so, but because this Hotend is compatible with the H2D and I happen to have that printer, I thought it would be fun to do a comparison. I was especially curious because the H2D's Hotend design is much closer to the Microswiss one than the A1 series Hotend. So I started off by loading up some ABS and doing some printing with the stock Hotend. I started with a 20 to 30 cubic millimeter per second test, and it completed without any problems. Because this printer uses a chamber heater, so it takes a bit longer to start a print, I threw a larger 30 to 50 cubic millimeter per second test for the second go. To my surprise, while I did see a little bit of imperfections on the inner walls, it completed the entire test without any really big defects or any sort of gaps in the wall. So I stepped it up to a 50 to 70 cubic millimeter per second test, and by 57 I started to see large gaps form and all sorts of under extrusion, so I stopped it there. Finally, it was time to swap in the new Hotend. The process for installing it on the H2D is very similar to the A series, but with a couple of small differences. The front cover removes in a similar way, but instead of needing your nail for leverage, just squeeze the top left and right with your fingers and pull it towards you. From here, it's the same latch mechanism to remove and replace your Hotend. However, when you're done swapping and power on the printer, you'll need to go to the Adjust menu. Select Nozzle and Extruder, and then press the Read Nozzle Info button. This will move the toolhead, and after reading the info on the new Hotend, the screen will update to display High Flow Hardened. Because of the results we got with the stock Hotend, I jumped right in and started off with the same 50 to 70 cubic millimeter per second test. It completed this entire test without any major gaps or under extrusions, but I did see some zits and imperfections starting to form around 65. Just for fun, I ran a final test of 70 to 85 cubic millimeters per second, but pretty much throughout the whole thing, I saw all sorts of inconsistencies and extrusion on the inner walls. The numbers for ABS with both the stock Hotend and the Microswiss Hotend were quite a bit larger than I was expecting, but even with that, I would back way off for my daily profile. This is mainly due to me using ABS almost exclusively for functional printing, be it another printer build or just some sort of part that's going to be under load. And for those types of prints, I want to make sure that I have maximum interlayer adhesion. Even though the high float Hotend showed no serious flaw up until 65 cubic millimeters per second, I would probably back this off to somewhere around 55. Generally, I like to have two primary profiles. One of them, which is strength for functional prints, and another one that's sort of like a draft or fast profile that's used for either rapidly prototyping something or printing out parts that are purely for display or something that's not going to be under any sort of load. My original plan was to install this onto the A1 Mini, and after these tests, I do think that that is going to be where it will have the biggest impact. And that's been the Microswiss CHT high flow Hotend for the Bambu Lab A and H series printers. I hope that you enjoyed this video and that you have a better understanding of what this Hotend is and some of its capabilities. I was really surprised with the output of both the PLA and PETG and did not think I was going to be running so many different flow tests. If you have any questions, let me know in the comments down below and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Microswiss to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every single week, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!